Hi, I'm Dave Gruber, a principal analyst at the Enterprise Strategy Group. In my role as an industry analyst, I have the privilege of talking with many of the brightest minds in the world of technology, many in industry roles supporting some of the biggest businesses in the world, and others who are early innovators and emerging companies with new ideas about how and where to leverage technology to advance the way we operate, communicate, and innovate. Well, today we find ourselves in a very special time period in technology history. The application of AI-enabled systems is fundamentally changing the way we are leveraging technology in virtually every aspect of our world. For many of us, we're exhilarated with the opportunity in front of us. And for others, we're chasing this exciting opportunity, but finding ourselves feeling unequipped to keep up. In cybersecurity, we've always lived in a world where we must know and apply our own tradecraft as the technology landscape that we're charged with securing evolves around us. As a researcher in cybersecurity, this shows up regularly when security leaders report that they struggle to keep up with the pace and diversity of their changing attack surface. The AI era is further accelerating this pace of change, exacerbating this phenomenon. So as organizations that we work within race to gain advantage through AI transformation, as security leaders, we're rightfully concerned about the potential risks that AI brings. Risk to reputation, protection, and privacy of sensitive data, our ability to meet regulatory and sovereignty needs, and the risk of novel cyber threat to the core operating systems and applications where AI is in use. And we live with these concerns in an environment that feels like a speeding train, carrying a mission-critical payload that will fuel the future success of our respective businesses. As a result, a careful balance is required. A balance that enables speed of innovation while managing in parallel the many risks associated with AI. As security leaders, we must think about AI in two parallel paths. First, we must develop effective strategies to securely enable the use of AI throughout our organizations. And second, we need to put AI to work on behalf of our own security agenda, leveraging AI to improve both the efficacy and efficiency of our security program. Our ESG research shows that 85% of organizations are already utilizing large language models for proprietary use, with another 13% reporting that they're in the process of developing their own models. Beyond proprietary LLM development, generative AI is widely utilized through third-party applications and services, supporting IT operations, software development, sales, research, and so much more. In support of this adoption, many organizations have created internal cross-functional teams, often referred to as centers of excellence, where they develop strategy, rationalize decisions, and manage AI initiatives. Many of you are likely already key members of this function. These centers of excellence are often also responsible for AI usage policies, in addition to working closely with development teams to establish secure DevOps practices. But many challenges exist. While most organizations have or are in process of developing acceptable use policies and controls for the use of generative AI, many security professionals admit that these controls have abundant weaknesses. Further, organizations already building generative AI applications are concerned about data loss, brand protection, due to risks of hallucination, response inaccuracy, prompt injection, and the risk of models potentially outputting offensive content. At the same time, CISOs worry about meeting sovereignty and compliance requirements, as their organizations struggle to implement strong data and model security, in addition to conforming to required governance standards. And while we're talking about governance, numerous regulatory bodies are rapidly establishing requirements to ensure the safe and ethical use of AI. Well, as these requirements become more widely enforced, security, risk, and compliance teams will need ready access to AI inventories and verification of controls and audit data. This will be challenging as inventory data will be constantly changing as the speed of innovation increases. Highly automated mechanisms capable of monitoring all aspects of the AI operating environment will therefore be required to keep up. So 3 foundational building blocks of AI security will be needed to address these challenges. First, an ability to continuously discover and understand all AI-related assets across development environments, operating infrastructure, and data pipelines. Second, control mechanisms capable of both setting and enforcing governance policies associated with the use of AI and the prevention of AI-specific threats. And finally, detection and investigation mechanisms that enable security teams to see and respond to AI threats and vulnerabilities. These three building blocks lay the foundation for securing AI. Let's take a closer look. For security teams to effectively secure the AI operating environment, they first need a reliable inventory of all AI assets in use within their infrastructure. This includes AI applications, models, and datasets. Further, security teams need visibility into both public and private models in use, including the data pipeline that feeds those models, and the configuration and operating status of all active controls used to protect and govern them. Beyond basic visibility, security teams need to map the relationships between all AI applications, data, and infrastructure. This inventory is core to the next two foundational building blocks. Let's see why. Securing this environment requires active AI security controls, including proactive controls to ensure model content quality and policy enforcement, together with active controls that can protect applications and models from malicious activity and attacks. An example of a proactive control is the ability to scan and detect malicious files or unsafe URLs that are contained within the models of use. Because many public models are commonly utilized, active monitoring and filtering for these same types of malicious or unsafe content could be necessary. An example of a proactive infrastructure control is the ability to detect and suggest the use of confidential compute to enable encryption and use that prevents the ability for insiders or external actors to access model weights. Another example of an active AI control is the ability to monitor for outside threats, such as prompt injection and jailbreak attempts. Finally, security operations teams need the ability to rapidly detect, investigate, and respond to active AI-related threats. And because AI threat investigation requires access to more than the commonly used security telemetry, new visibility into model interaction, model contents, and model controls is needed. Beyond external threats, issues involving the AI data pipeline may require security teams to work closely with application and AI model developers to respond to model data-related issues. Ideally, all these capabilities will be integrated with primary detection and response mechanisms, enabling automation and workflow support. So security leaders face massive responsibility today in ensuring the secure development and operations of AI applications and the data used within them. At the same time, they have an opportunity to become a key enabler of AI transformation within their broader functional organizations. Establishing early foundational AI security infrastructure and controls will set the stage for this enablement. To summarize, securing AI requires, first, an ability to discover, inventory, and understand all AI infrastructure and assets used across development environments, operating infrastructure, and data pipelines. Second, the ability to implement both proactive and active security controls that are aligned to rapidly changing policies and operating infrastructure. And finally, detection and response mechanisms capable of monitoring and responding to threats associated with AI applications, data, and operating infrastructure. These foundational capabilities should both support the individual needs of security and application development teams, together with enabling active collaboration in assessing security posture, mitigating risk, and safeguarding AI workloads. Oh, and all without slowing down the pace of AI innovation. Hey, meanwhile, opportunities abound for leveraging AI in security. I just completed a research project looking closely at the security operations function within the AI era. The research revealed that for the first time in the past 5 years, the scales are actually tipping in a positive direction, with security operations finally becoming easier instead of more challenging. And of course, the use of generative AI is a significant contributing factor. Other top 5 factors included tools consolidation, improvements to operationalizing threat intelligence, solution upgrades that led to more efficient detection and response activities, and of course, help from third-party security service providers. The same survey also tells us that 3/4 of organizations are using generative AI-enabled solutions daily, of which half think that Gen AI is going to make a significant impact on their security operations function. Oh, and most of these organizations are assigning specialized roles to lead or focus on applying generative AI solutions within their functions. So these are exciting times that we'll surely recognize as a turning point in how technology supports so much of what and how we operate, differentiate, and innovate. To make all this happen, we must collaborate at a new level, sharing our experiences, learnings, and opportunities as we harness the newfound power of AI together. Thank you for your time and attention today. Enjoy the rest of the program.
Hi everyone, my name is Naveed Makhani and I lead our AI protection product area, and I'll be joined later by my colleague Manjri Sharda, who is the PM for Model Armor, one of our key AI protection capabilities. There's a lot of excitement in the market for how AI can transform businesses, but we all want to do this securely. This survey from McKinsey with over 1,000 participants shows that security, privacy, and compliance are ranked among the biggest Gen AI risks, and security in particular is the second highest risk that customers are actively investing to mitigate. To make this more concrete, some of you may have heard about a new Gen AI model called DeepSeek that emerged in the last couple of months. There's already been millions of downloads, and there's likely many development teams that are using this in production. And you can see from the headline here that the model can be easily manipulated into generating harmful content. And here are some real-world examples of the unintended consequences that can occur when a Gen AI model is manipulated. And you can tell from these headlines that there are some serious implications to customer experiences and brand reputations. And that's why we're investing so heavily to enable the secure, private, and compliant use of AI so that our customers can accelerate their AI transformations. We recently introduced AI protection to help manage risk across the entire AI lifecycle. And we do that by first automating the discovery of AI in your environment, which includes discovering AI assets like models and training data sets. And then once we have this inventory, we can run it through our risk engine to identify the riskiest AI issues. And then lastly, we bring in the ability to detect, investigate, and respond to threats against AI. And all of this is delivered in a single pane of glass through Security Command Center. Now, AI protection starts with visibility, and we provide that visibility by automating the discovery of AI assets in an organization. And so here you can see that there are 14 projects using Vertex AI, of which some are using models like Gemini and Llama without any customization, and other projects are customizing models through fine-tuning and training. And these model customizations are driven by 80 datasets, of which 27 have sensitive data in them. Now, all of this rich AI inventory is then input into our risk engine, which performs virtual red teaming to surface the riskiest AI issues that could, for example, expose training data or toxic combinations that could lead to a model being hijacked. And here we can see a visualization of the 5 riskiest AI issues. And the objective here is to separate the signal from the noise and focus your team's limited resources on remediating the highest risk AI issues. Now, in this particular example, we see that virtual red teaming has prioritized an issue where a data set that is used to train a model is stored in a storage bucket that's publicly exposed. That opens us up to data poisoning risk, where a bad actor could alter the training data to change the behavior of the model in future training runs. Now, another thing we do with our AI inventory is identify where models are being used, but they aren't protected by Model Armor. Now, what is Model Armor? Model Armor is a key part of our AI protection strategy because it enables organizations to put filters in place to detect if sensitive data is leaking out of a model, or a customer support chatbot talks about competitors, or a social media agent creates posts with offensive content. So let's go through a flow now to so you can get a better understanding for how Model Armor works. The first step in the flow is the user enters a prompt, and that prompt then comes into the GenAI powered application. at which point Model Armor evaluates whether the prompt complies with the organization's security and responsible AI policies. If it does comply, then in the second step, the prompt goes to the LLM. And this can be any LLM, not just Google's models. We're supporting multi-cloud, multi-model architectures to enable customer choice. And then in the third step, the LLM generates a response, which Model Armor again evaluates to ensure that the response complies with company policy, which, as an example, may involve a screening for PII. And then lastly, in the fourth step, we send the response back to the user. Now, all of this screening that we're doing is driven off powerful Google technology, including a content safety model to detect offensive content, a prompt safety model to detect prompt injection and jailbreak attempts, and then the full power of our sensitive data protection service to identify, mask, and redact sensitive data, and then Google antivirus and safe browsing to detect malicious files or unsafe URLs. And all of this is available through that single Model Armor service, the single Model Armor API, and we'll continue to add to this set of capabilities over time. Now I'm going to hand it over to Manjari, who's going to take us through a demo.
Thanks, Naveed. Hi, everyone. This is Manjari. I'm the product manager for Model Armor. Today, I'm excited to demonstrate to you how we're going to protect your GenAI application. I'm going to show you two things. One, how easy it is to set it up, and two, how powerful it is to protect the application. Let's get started. First, let's see how easy it is to set up Model Armor. The first step is to create a template. A template defines the specific protections needed by your application. Creating a template is easy and straightforward. All you need to do is select the detections needed by your application, such as malicious URL, prompt injection or jailbreak, sensitive data protection, or the responsible AI filters. You can also choose the confidence level needed by the detectors. So for example, for prompt injection, I'm going to select medium and above. For sensitive data, I'm going to select basic. This will allow me to detect and redact PII information like social security number or credit card numbers. And finally, I'll select the responsible AI filters and I can change the confidence levels on each one of them. And that's it. Once you've created a template, you can use the template ID to call the Model Armor API. Great. Now that you've set some policies, we can see Model Armor in action. We have a sample UI application that's integrated with Model Armor and some foundational models like Gemini and Llama. Let's start the demo by sending the direct prompt. Yes, you can see that Llama did not respond based on the safety guardrails inbuilt into Llama. Let's try to circumvent these by using a more convoluted prompt. And you'll notice I haven't selected Model Armor to protect the model. Oh well, we were able to fool Llama and get it to respond by using a more convoluted prompt. Now, what if we use Model Armor to protect it? I'm going to send it the same prompt. Well, there you can see Model Armor found a jailbreak violation. You can see it says match found on top. And if you scroll down to the filter under PII and jailbreak, you can see the match was found there. All right, let's try another example. This time I'm going to send it a malicious URL. Again, Model Armor found a violation. It will give a match found on the top result. And under the malicious URL filter, it will provide additional details. One last example. In this case, I do not want to send PII information to the model. And I will select a sensitive data protection template to detect and redact PII information before sending it to the model. There, you can see in the prompt that was sent to the model, the PII information was redacted. You can also see that in the raw output, where email address and personal name was redacted. As you can see, Model Armor provides a comprehensive set of guardrails for your GenAI application. It's easy to set up and can be used by both the developer and the security teams. We will be adding many more features over the course of this year. and we look forward to showing you more next time. For now, I'm going to hand it back to Naveed.
Thanks for the great demo, Manjari. So, how can customers deploy Model Armor? Well, for developers who want granular control, our REST API offers complete flexibility. They can integrate Model Armor anywhere in their application stack, and they can also leverage Apogee to call Model Armor's REST API. And beyond the REST API, we're introducing options for inline visibility and policy enforcement, starting with a native integration through Vertex AI, which automatically routes prompts and responses to Model Armor. Now, this is really powerful because no application changes are required. You can keep calling Gemini through Vertex like you do today and simply turn this feature on in the console and gain immediate visibility. We're also extending this same concept to our network stack, where we're delivering integrations with our cloud networking products, including the GKE gateway, load balancers, and the secure web proxy. Now, the key takeaway here is choice. We're giving you the flexibility to choose the deployment model that best suits your needs. And we're making adoption as frictionless as possible by enabling you to get visibility without making any app changes. We're also thinking deeply about the end-to-end experience, and that means making it easy for you to manage the full lifecycle, starting with the discovery phase, where we identify GenAI models that aren't protected by Model Armor, and then guiding users to add Model Armor protection without making any changes to their app. And then lastly, security can monitor Model Armor detections directly from Security Command Center. So we're trying with this approach to make it as easy as possible for you to manage the end-to-end lifecycle. Now, we spent a lot of today's session spotlighting Model Armor, but I do want to call out that Model Armor is one of many AI protection capabilities available today. So I encourage you to learn more about all the ways AI protection can help you accelerate your AI transformation. And you can do that by visiting our Securing AI website. And you can also learn more about this area by reading a new white paper from the Enterprise Strategy Group. And of course, please reach out to your account team if you'd like to evaluate Model Armor or any of the other AI protection capabilities we offer. That's it for our session today. So thank you for joining, and I hope you enjoy the rest of the event. Bye, everyone.
Hi, everyone. Thanks for joining us today for Google Security Talks. My name is Neil Karen, and I'm a consulting leader for Mandiant in our strategic services practice. So what are we talking about today? For today, we're going to be covering some higher level topics intentionally designed to create the connective tissue between governance and operational considerations when it comes to AI and threat modeling. But before we begin, I want to first quickly define the topic of threat modeling for AI enablement. For the purposes of this discussion, it's a structured approach for identifying and mitigating security risks to AI systems, therefore ensuring resources can be provisioned to support business needs. So what does that mean? What it boils down to is really around how threat modeling can be used to model and identify risks that could compromise the ability of an organization to use AI to enable their critical business services. In cases where that dependency is material to an organization's day-to-day operations, compromises of those systems can have severe consequences. So as part of the discussion today, we're intentionally going to be referencing AI in the broadest sense. So if you hear it being used somewhat interchangeably, we're aware that AI has several subdomains such as machine learning, Gen AI, fuzzy logic, etc. So why is this important? Right now, the application of AI is becoming an integral part of enterprise operations, providing efficiencies and enhanced decision-making capabilities across a variety of industry sectors. However, its integration introduces unique security challenges that require a structured approach to highlight risks requiring mitigation and the detection and response strategies needed to be put into place to protect the business, but enable users in parallel. As cyber strategists, we understand the tension between speed and security. Businesses need to move fast, but neglecting security can lead to material consequences. So today we'll dive into how threat modeling can be your strategic tool for securing AI innovation, enabling you to move forward in a way that aligns to your business, but creates a foundation for repeatability and consistency. Topics we're going to be touching on include key business use cases driving AI adoption, but also additional things to think about, and how a layered framework approach can enable threat modeling to help surface risks in a repeatable way. So let's pivot into some AI use cases for a moment. Today's AI's impact is undeniable, and its strategic application is reshaping business operations. Innovation leveraging AI is accelerating new product development by enabling rapid prototyping, simulation, and testing. AI-powered research tools are enabling breakthroughs in fields like medicine, manufacturing, and engineering. And generative AI is enabling novel creativity processes such as content generation and design. But with any innovation, there are also the reflective risk considerations that need to be thought about when adopting and enabling new capabilities. So let's lean into that for a moment. Enhance customer experience. Today, AI-powered chatbots are evolving beyond simple queries. They're now providing personalized context-aware support and even proactively engaging customers based on predicted needs, translating into increased customer satisfaction and loyalty. Personalized recommendations are driving sales and engagement by tailoring product offerings and content to individual preferences, which is vital in competitive market spaces where customer retention is critical. And predictive customer service leverages AI to anticipate customer issues and resolve them before they escalate, reducing support costs and improving customer experience. So when we take all those into account, the possibilities are endless, but it's important to consider the security aspect on what needs to be done to ensure those capabilities are allowed to continue functioning. For example, these systems handle vast amounts of personal data, making them prime targets for data breaches and privacy violations. Threat modeling must address risks like data exfiltration and unauthorized access, and how countermeasures can be developed where they can be placed to safeguard the system as well. Now, if we look into operational efficiency, this focuses on the automation of repetitive tasks such as data entry and processing, with the goal of freeing up human capital for more strategic initiatives, boosting productivity and reducing operational costs. Predictive maintenance also uses AI to analyze sensor data and anticipate equipment failures, minimizing downtime and optimizing maintenance schedules. This is something that is crucial in industries with critical infrastructure. And supply chain optimizes and leverages AI to forecast demand, manage inventory, and optimize logistics, improving efficiency and reducing costs. So, what are the concerns with this? If we double click on that, AI-driven automation can be disrupted by adversarial attacks, leading to operational disruptions and financial losses for an organization, ultimately leading to brand and reputational damage. Threat modeling should focus on ensuring how the resilience of these systems can be achieved and maintained. Finally, let's briefly touch on data-driven insights. Advanced analytics today enable businesses to extract valuable insights from large data sets, driving informed decision-making and identifying new opportunities. AI-powered fraud detection systems can identify and prevent fraudulent activities in real time, minimizing financial losses and protecting sensitive data and customers. And AI risk assessment tools use AI to analyze complex data patterns and identify potential risks, enabling proactive risk management. Often, these types of systems have unique logical correlation capabilities that can increase their value and attractiveness to attackers. Since these systems handle sensitive data and proprietary algorithms, it elevates the risk to data breaches and intellectual property theft. Here, threat modeling can help address risks like model inversion, data exfiltration, leading to unintended disclosures or misappropriation. Now let's move on to the next section and look at some broader context for things to think about. So, taking a look at a study that was conducted by McKinsey back in 2024, there were some really interesting insights around generative AI and some of the considerations that organizations had in terms of risk and what they consider relevant and working to mitigate. From the survey, results indicated that cybersecurity was in the top 3 for risks and also a type of risk being actively mitigated. So what this means is that organizations aren't blindly going through the process of consuming AI, but are aware of some of the risks that come with these types of technologies. And it's our jobs as security practitioners to find the best way to bridge that enablement within the context of the business and how our use of AI systems, whether to enable other systems or become a core capability itself, need to be safeguarded. The business use cases outlined earlier demonstrate the transformative power of AI, but they also highlight the importance of proactive security measures. As highlighted in a recent Google Threat Intelligence report, adversarial misuse of AI is a growing concern. These threats aren't abstract. They represent real risks to business continuity and revenue streams. So let's dig into a few of these to better understand what each of them are. Data poisoning. So this involves the deliberate introduction of malicious or manipulated data into the training data set of an AI model. The goal is to skew the model's output, causing it to make incorrect predictions or decisions. This can have severe consequences, especially in revenue-generating applications. So, for example, consider an AI-powered recommendation engine used by an e-commerce platform. If attackers poison the training data with false customer preferences, the engine might start recommending low-quality or irrelevant products that can lead to decreased customer satisfaction, reduced sales, and damage to the brand's reputation. If we look at model inversion, this is a technique used to reconstruct sensitive data from a trained AI model. Attackers can exploit vulnerabilities in the model to extract information about the training data, potentially revealing confidential customer data or proprietary algorithms. Bias and discrimination. AI systems can perpetuate or amplify existing biases present in the training data. This can lead to discriminatory outcomes, damaging the organization's reputation, and potentially resulting in legal liabilities. Adversarial attacks. These attacks exploit vulnerabilities in AI algorithms to cause malfunctions or provide false information. Attackers can manipulate input data to trick the model into making incorrect predictions, leading to financial losses or operational disruptions. This can be as simple as changing a few pixels of an image to fool an image recognition system, for example. And data exposure. This is the unintentional or unauthorized disclosure of sensitive information handled by an AI system. This can occur due to misconfigurations, vulnerabilities, or insider threats. So as we look at some of the threat concerns and risk scenarios, data quality and security become very critical within AI systems. So how are organizations today currently addressing some of these AI security concerns? Currently, there is a broad spectrum of adoption of AI across industry verticals. What many organizations have started to do is to try to be as methodical as possible and work from a top-down approach and figure out what is the right AI solution for the organization and what is the right business driver for its use. Quickly following that is ensuring the right policies and governance are in place to allow individuals to safely adopt AI-enabled practices within their day-to-day operations. As part of that, they're also identifying which are approved AI partners and solutions so that employees and users understand that the solutions being provided are approved to work with. There have been cases and examples of individuals introducing a risk to their environment by using unauthorized sources for AI capabilities, sometimes in certain cases leading to malicious software being introduced to a client environment, leading to investigations and breaches. The other area where organizations are enhancing support for AI enablement is around designing the patterns and practices that are to be architected within the environment to make sure that what is being used is as safe and secure as possible. This particular area is a strong connection point for capabilities like threat modeling. As you build an architecture and templates for adoption, it becomes really important to make sure that the technologies are assessed for risk, that countermeasures or mitigations are put into place, and so that people can safely use these technologies. So as organizations continue their AI journey, one thing we often recommend to clients before jumping into threat modeling is really understanding the business context. To do that, we often recommend trying to develop an understanding of what are crown jewel systems in the organization. And the reason we often recommend this is because organizations, especially when it comes to AI, will more likely embed those AI capabilities within systems of highest importance and highest criticality, since those are likely to be the ones to enhance revenue generating capabilities or customer retention. So whether it's the AI enabled system or the AI itself that's become the crown jewel, it's important to know the context. So when we think about that context, we want to focus threat modeling on those systems of highest criticality where AI is also being enabled, because security risks that materialize within those systems by definition are those that will have the highest impact if compromised. From Google's perspective, we have what's known as the Secure AI Framework, or SAFE. And within that framework, there are key tenets that align heavily to the crown jewels approach for context development. Why this context is important is that as the threat modeling process identifies threat vectors and attack paths, it becomes easier to create the connective tissue between the models and critical business systems. So now I want to pivot into the final section where we're going to talk a little bit more about frameworks and threat modeling more tactically, with the intent to demonstrate how understanding the business use cases can tie everything together. So now let's assume that we have a good understanding of business context and we have a good handle of our AI-enabled crown jewels. So now we want to lean into threat modeling. Often what we recommend is anchoring your threat modeling to known standards, but something that allows for repeatable practices. To do that, we suggest having a foundational governance model that captures the key guiding principles, and as you progress layer by layer, the focus of the framework becomes more tactical and operational, leaning more into threat context. When you look at the layers, these are simply suggestions of known frameworks, but the ones being reinforced will likely continue to see development over time. But as it currently exists, the NIST AI RMF framework is a really great one for governance and overall risk management of AI systems, and acts as a really good grounding point for organizations. Google Safe framework is a really good one to look at as well, as it starts to focus on the end-to-end security of things like machine learning. But the key principles within there allow an organization to think a little more specifically around key capabilities that we want to have in place. So for example, deployment and monitoring. And it's also something we can synchronize with other frameworks like the NIST AI RMF. As we continue to progress through the value chain, we're now getting into specifics of the models themselves. So now we're looking into things like MITRE ATLAS, where we can get more into the AI threat landscape and can start leveraging things like the attack lifecycle, focusing on very specific phases and the tactics, techniques, and procedures that can be utilized by attackers. One step further is getting into even more specific areas around some of the threats in terms of what exploits could be utilized within specific contexts. So something like OWASP's top 10 security risks for LLMs is also a really great resource. So a final note on why a layered approach is really important and critical for something like threat modeling is that it allows for consistent use and repeatability from that foundational governance layer all the way to those operational tactical controls and tactics, techniques, and procedures that attackers may utilize against an organization's systems. So now that we have a tiered framework for AI threat modeling, let's actually explore what is threat modeling. If we look at threat modeling by definition, the goal is to essentially unpack a system into its components and connections and understand the connections between those components. Through that process, we are looking to identify the threats to each of the components or connections, then assign a risk to each of those areas and a level of prioritization to understand what the impact would be from a severity perspective. Adam Shostak's threat modeling 4 questions approach is designed to provide a simple yet effective model for conducting threat modeling. Their primary purpose is to help build more secure systems by guiding them through a structured process of identifying, analyzing, and addressing potential security issues. So what do the 4 questions aim to do? What are we working on? This question is about scoping and understanding. It helps us to define the boundaries of what is being analyzed, ensuring that everyone involved has a clear understanding of the system, application, or feature being considered. What can go wrong? This is the core of threat modeling and threat identification. It allows participants to brainstorm and identify potential threats, vulnerabilities, and attack vectors that could impact the system. What are we going to do about it? This question focuses on the mitigation and response planning. It drives the team to develop strategies and countermeasures to address the identified threats. This could also involve implementing security controls, redesigning parts of the system, or accepting certain risks as they are. And finally, did we do a good job? This question is about continuous improvement. It encourages looking back on the threat modeling process itself to assess its effectiveness and identify areas for improvement. The 4 questions provide a simple, repeatable, and adaptable method that can be used in various contexts and at different stages of a project. So now we're at the point where we understand the business use cases of why we're utilizing AI-enabled capabilities, the critical systems or crown jewels that are being propped up by these new AI capabilities for efficiency gains or revenue growth, and we're reconciling that back into our AI layered governance model and starting to do threat modeling. So what are we ultimately trying to do and accomplish? Fundamentally, if we look at our AI pipeline, we're trying to understand how data gathering occurs, data cleaning, model training, rollout to production. In doing so, we want to define the AI pipeline. We want to identify critical components, identify the key attack vectors, develop detection and response capabilities, map to existing controls and mitigations, and identify remediations and implement controls to close those gaps. Through the threat modeling process, once we understand the control uplifts that are required for things like detection and response relative to the identified attack paths, we can then develop a more holistic picture around what is the business context, the systems of criticality, and the associated attack paths and the required mitigations. By now connecting those mitigations back to the crown jewel systems, we can also comment on the AI business use cases that if these particular security investments are not made, may prevent those use cases from materializing. This can be the difference between an organization being able to provide its individuals and resources the tools needed to enhance customer experience and gain operational efficiencies, or simply maintain status quo. So, with everything described and everything said so far, an important consideration is also resourcing and personnel. So, those that would actually perform these capabilities. Threat modeling is a very specific skill set and one that can definitely be developed, but does take time. And when you align that to a developing area such as AI, it's really important to ensure that the right skills and the right knowledge are put to use at the right time. That said, leveraging technology and tools to enable processes like threat modeling is also something organizations should seriously take a look at. For example, Google has an interactive model with a SAFE framework that allows individuals to do exploratory work around some of those bigger risk areas like AI, model inversion, or data poisoning, and allows you to really think through some of the big things we generally need to think about when it comes to these types of AI risks. Another important aspect of tools enablement are things like scalability, efficiencies, and also consistency and repeatability. By having a common resource used by multiple individuals, organizations can minimize the use of inconsistent methodologies or frameworks being applied in an inconsistent way across the organization. Once again, when you align yourself to a structured tiered framework, it allows individuals to understand not only the rationale as to why something is being done, but how the findings can also reconcile back to the larger AI strategy and overarching governance model. So as part of all this, we've discussed several different frameworks and resources, but have provided information and links here to both the Google SAFE framework and also Mandiant's AI services portfolio. So I want to thank everyone for listening today as we discuss threat modeling for AI and how the approach in this particular session was intended to speak to the overarching approach and the importance of threat modeling within the business context, how understanding of the business use cases for AI can be used to figure out where threat modeling falls into place, the governance frameworks to consider when you're putting models together, and some of the systematic process to follow when going about this. Hopefully everyone found this useful and beneficial. Have a great rest of the day.
Hello, welcome to the panel, How Google Does It, Making Threat Detection Scalable and Secure in Our Own Cloud. With us today is Seth Vargo, UTL for Google's internal use of Google Cloud, and Tim Wynn, Global Lead of Threat Detection here at Google. So I want to start with a question that reveals a mystery. Google actually uses cloud computing. We use our own cloud. So we should probably focus on some of the lessons we've learned from that. Ideally, that the customers can use. So Seth, how does Google secure its own cloud use?
Yeah, great question, Anton. And I think first I want to talk about the scale, because that scale is really important when we talk about the tools and the technologies that we have. We have over 40 million GCP projects used at Google, used by tens of thousands of engineers across our different business units, whether that's ads or Chrome or Google Cloud itself. And we have kind of turtles all the way down in some cases, where you look at Google Cloud products like Vertex AI, where Vertex AI actually runs on top of another Google Cloud project, Google Kubernetes Engine, which runs on top of another Google Cloud project, Google Compute Engine, which then runs on top of our private cloud, which we call Borg. So the landscape is incredibly complex, because that means that a vulnerability or a misconfiguration in any part of that stack could lead to an attacker or a malicious compromise or an outage that could affect customers. So when we look at the size and the scale of Google's use of GCP, we really have all of the things. We have products that are customer facing. We have consumer facing products and services. And then we also have a lot of internal tools, business, like line of business applications. You can think of them as like engineering productivity or internal tools. And each of those has like a slightly different threat model with respect to, are they accessible to the public internet? Or are they only available to employees? So when we look at securing Google at scale, we have to take all of those different threat models into account. We also have to take into account things like rate limiting and quota management, which we run into very frequently. But we have an internal system where we leverage the public GCP APIs, largely the Google org policy service, to create a hierarchy and a collection of hierarchies where we deploy these organizational policies in different parts of the folders in the resource hierarchy. So we can say, this folder has this threat model, and therefore it has these set of organizational policies, and therefore you can do X but not do Y. For example, you might be able to do something risky or perceived more risky, but it doesn't have access to the public internet, so your threat model is contained to internal employees.
So that sounds like a lot of this is hard work, while there's maybe some magic to it, right?
I wouldn't say there's magic. There's definitely lots of hard engineering, but when it comes to securing our own use of GCP, we try to use GCP as much like an external customer as we can. That means public APIs, public products, public features, and Google's actually been, like Google internally, has been a big advocate of some of the features that have then been made into the platform itself. Notably things like IAM deny, which is the ability to write policies that supersede allow rules, particularly, again, in the resource hierarchy. So we do rely heavily on the resource hierarchy as a kind of an enforcement mechanism, as well as the organizational policy service. And we write our own custom org policies as well whenever we have a Google-specific need that the default org policies can't solve or need additional invariants.
That makes sense. So now we want to turn our attention to Tim, who deals with DNR. And sometimes what I observed at various organizations, there's a security hygiene, securing the environment, and there's beautiful isolated SOC on the hill that does DNR, and they don't really talk together all that much. So Google clearly bridges the gap between securing the environment and doing detection and response. How do we do it? How do we balance this?
I think there's a baseline realization at Google, an explicit and conscientious one, that we're two sides of the same coin. So really, just mechanically, Seth and I talk, I think, basically every week. We cross paths all the time. We align all the time, and the reason for that is that we know that, one, when we threat model an environment, that we have to bring different perspectives to that threat modeling. But two, for all of the awesome controls and capabilities that Seth is building into our usage of cloud, attackers are similarly clever, similarly persistent, and very, very, very motivated to circumvent, break through, and try to compromise the underlying layers of all the controls that we put in. So the partnership there, I think, is a natural one, but also it's a critical one, because where we have to balance the usability and the product itself, maybe even allowing remote code execution, for example, or allowing, like Seth said, risky type workflows. I depend completely on Seth and his team to really see where the most critical assets are, where the most critical kind of pathways and lateral movement kind of threats are, and so that allows me to focus my energies, focus my detections where they matter most, or where the attacker can do the most damage. So yeah, I mean that it seems intuitive, but I think we've made it very, very explicit at Google that what we call the pre-fail and the post-fail sides are working together. Are working together in concert to really drive the right outcomes.
So instead of your AI agent calling his AI agent, you guys actually talk on the phone. That sounds kind of very 90s.
There are those phones. We have cameras here, right? And we have the video conferencing units. But yeah, absolutely, we call it. There's no substitute for collaboration, for working together, for having those shared problems that we identify as neither of us can solve these problems by ourselves.
Yeah. So what would we tell clients, apart from, say, Google Cloud users, apart from try talking to them if you're a DNR or SOC person and you want to somehow figure out the interaction model with people who deal with hygiene? Our advice is you guys should talk, right? Is there any magic to it apart from you really should do it?
I think, and I would love Seth's take on this to see whether this approach works for him and his team. But where our approach has been to really come in with a helping hand, right? And really kind of highlight that, again, we are driving the right, we're all behind the same purpose. We're all driving the right outcomes. We're all driving the same outcomes. And so, where I come in was kind of with a few kind of concrete things that I need, and they're actually really, really non-controversial. Mm-hmm. One, I need logs. You can't detect what you can't see, right? And two, I probably need a little bit of tuning in the logs, because Google is actually like a lot of other enterprise companies. we cannot ingest every single thing and retain it forever, right? And it's just too costly in terms of storage, compute, network bandwidth, all of that stuff. So we work in conjunction with the product teams. We work in conjunction with the pre-fail, right, security teams to really tune down the logs and tune it down so that we can identify the right threats and build the right types of detection signals. So yeah, kind of having that collaborative approach from the very onset and kind of coming in with a helpful mindset versus a the sky is falling type mindset. I think has really helped to engender the right types of conversations.
Yeah, I definitely agree. We really try to go carrot before stick where possible. And there's a lot of value proposition when we go to
We do have a stick though, right?
The carrot is actually attached to a stick.
Oh yes, that's right.
So
it's like you.
It's not far behind, but it's great to like go to a team and say, hey, we have this new landing zone. If you go into this landing zone, we can assure you that you're meeting the compliance requirements and the security and privacy requirements. And over time, we can up-level those with basically zero toil or work from your team. Also, we can't guarantee it, but we can, have strong probability that like Tim is never going to come knocking on your door being like, hey, what's going on? And once we have a kind of critical mass or corpus of people running in that environment, and we have strong assurances that it meets the needs of the business and it's not hindering things like developer productivity or velocity, then we can come in with the stick and say, hey, like all of your colleagues are successful in this environment. Now it's time for you to move because you're creating risk for the business. But we try to start with the carrot because, I've worked in this space and intersection of this space for a long time. Like we get it wrong sometimes. And sometimes we come in with too heavy of a hand and we get in the way of the business and the needs of the business. And that's why we try to start small with the carrot, have pilots, and then gradually expand outward. And then at some point, the carrot gets pulled off of the stick and it does become the stick.
Yeah, and to the stick point, really, my function, detection response, really only has one remediating stick, and that is to tear everything down and rebuild it. That's the only way when a compromise happens that we can be assured that the attacker is no longer there, that the environment is clean, that we can really trust that environment again. So we don't have to enumerate that too often. We do have some samples in our back pocket that we can draw from in terms of providing that historical data. But yeah, I think that's very well understood that ultimately were an environment to be compromised, were risk to be endured for too long, then yes, it would be very, very disruptive to go through that remediation.
So I want to switch gears very briefly to something slightly more technical than people talking on JVC, namely that one particular piece of tech stack that is used both by sort of pre-fail hygiene side and the post-fail detection side is, of course, asset management. And it's possibly a fairly boring subject, but it seems like both of your teams make heavy use of asset management and fleet management. So we probably have some magic in the area given the scale. So can you share some insights about how we tackle asset management to ensure both accuracy, efficiency, and of course, utility for both teams?
Yeah, I can definitely take a stab, and then maybe Tim, if you want to chime in after. So speaking kind of purely from the GCP side, our initial magic is we use cloud asset inventory. However, as I mentioned earlier, we have over 40 million GCP projects. We have over 10,000 GCP organizations. And across those organizations and projects, we have tens of billions, if not hundreds of billions. I haven't looked at the recent numbers of assets. So again, we're talking about a size and a scale where things start to break down. Like your traditional, like just shove it in a database doesn't work when you have 100 billion assets and you're pulling those every 5 minutes to create kind of a time series database of the assets and the criticality of those assets. So we leverage the GCP APIs to specifically Cloud Asset Inventory, and we've partnered with Cloud Asset Inventory to bring some of our like internal computation into the upstream product. Things like effective tags and effective IAM policies, which are very important for us because, as I mentioned earlier, we use the resource hierarchy. But now it benefits all GCP customers because we've been able to get those features upstreamed. But once we get that snapshot, we have kind of an internal data lake where we maintain different granularities of this data over time. So I don't know if you want to call this magic, computer science, or just good software engineering, but basically as time goes on, the granularity of the time series becomes longer, and we start to compress data because the information about the asset becomes less relevant as we move into months or even years of the asset's existence. But when we look at like our 5-minute or 30-minute exports, we have I don't know if you've ever seen the cloud asset inventory, but like it's basically a giant JSON payload of every attribute of the resource. But then as time goes on, we start to compress that data, we munge the data, we drop some fields because they become less relevant from like an asset management perspective over time. There's a number of teams at Google that then feed from that data lake, which my team owns. We have like our vulnerability management team that is looking at asset criticality to understand ownership, anomaly detection, and they have a lot of secret sauce that's very Google specific. But I think, as you can imagine, we also have vendor supplied software in this space that is doing analysis and aggregation. And then I'd be remiss if I didn't mention AI in some way, shape, or form. So leveraging artificial intelligence and Gemini to look at that data and try to do things like anomaly detection. We also use like one of the interesting things about that data set is it might contain information that we don't want everybody at Google to know, right? We have projects and teams that are not publicly disclosed within the company. They're doing a clandestine research project for a next generation thing. So there's also the ability to like restrict and ACL that table so that certain teams only have access to other teams' assets and traditional ACLing. But again, you're talking about hundreds of billions of resources. So maybe the traditional solution you would use there wouldn't scale to Google's internal use, but under the hood, it looks a lot like an ACL on a database, like a Postgres database. Yeah. I don't know, Tim, do you have anything you want to add?
Yeah, I mean, I think that's amazing. And one is my team depends critically on the work that Seth is doing in terms of tagging those assets, in terms of understanding those assets. The more that we understand about the many, many, many millions of projects and organizations and whatnot in our own usage cloud, obviously, and you can imagine how critical that is for us to understand, where to focus our efforts. But from my standpoint, Google's usage of cloud, or for my day job, Google's usage of cloud is one of about 500 log sources that I have, right? Mm-hmm. And so, you can imagine all the work that Seth and his team has done, other teams have done as well, and then I ingest all those logs. So the number one thing that our team has done to reason about badness, or to reason about what is happening across the vastness of Alphabet, is we normalize our logs. That's it. Those are the three magic words there that actually, like Seth said, aren't really magic. It's effort, it's a little bit of data science, and it's a lot of software engineering that go into taking all of these log sources, taking all of these different types of field types, different things, different ways people call different things, and then really modeling it to, hey, what is an asset? What is a user ID? What is a URI? What is a process? How do you reconstruct process trees? How do you reason about the world around you without having to build a detection signal from scratch every single time? So you can imagine that we don't want to build 450 versions of a bad execution signal or a simple tripwire, right? And so in order to be able to build one signal for the bad activity that we're looking for, we need to then take all of the different types of log sources, Seth's and everybody else's, make sure, again, we normalize it so that we can reason about the same types of behaviors, and then output that to our analysts, output that to our engineers, so that we can ultimately have human eyes on what looks to be malicious activity, what looks to be attempts at hacking Google.
I think the normalization, they call to use normalized logs rather than 300 formats. Sounds like something I would have said to a customer in 2003, being at a SIM vendor. The problem is not that it's dated advice. That's correct advice, and people just haven't done it diligently enough in many cases. So I'm super happy to hear you say that, because ultimately, if for me as an analyst, normalized logs are just better. They're more clear, they're more easy to connectable. AI can understand them better. So to me, this is interesting how this remains true for the last 20, 30, maybe even more years, and yet I've seen people who don't really, focus there.
Yeah, I mean, it's the old truism, right? I mean, structured data is better than unstructured data. Now, we know we've invented an entire computing industry around reasoning about unstructured data. We all have data lakes. Seth has a data lake. I have a data lake. I'm not claiming that all of my data is perfectly structured, but you can't just throw junk in there and hope to to find something good out of that, right? And you can't, and you absolutely cannot do that at scale. You would drown, you would lose, you would pick your most negative word, and you're there.
Yes. That makes sense. So I want to switch gears a little bit, because when we think about the cloud usage, a lot of people still struggle with misconfigured cloud services. And of course, I am 100% sure we never misconfigure any of our own stuff. But how come we do that? Like, what is our approach to reducing the cloud misconfigurations? Maybe it's a Seth question more than Tim's, but then Tim gets to pick up the pieces if in cases we do that. So maybe it's a joint question.
I mean, like all things in security, right? It's defense in depth, it's layers of the onion. So I think of this more like a coffee filter where, I try to prevent as much stuff as possible, but every once in a while, some things slip through the cracks. Everything we do at Google is infrastructure as code. And you would be surprised how much this reduces misconfiguration, because we do things like enforce two-party code review. So forget about policies, forget about security, just bugs and everything. Like, requiring another human to look at the infrastructure changes before they're approved and deployed to the target environment, honestly, like, I would say that probably gets you 80% there. Don't quote me. I'm not an analyst, but it gets you super far. And then when it comes to security policies, we have the way our internal code review system works at Google. If a team is modifying a security policy, that two-party code review has to come from a security engineer who has expertise in that space. So this is how we prevent misconfigurations kind of shifting left, if you will. I already talked a little bit about how we shift right as well with the org policy service. So we have organizational policies deployed at scale. They target different parts of the resource hierarchy. So even if something does slip through and somebody tries to open up a firewall port that they shouldn't, we leverage like the hierarchical firewall policies of GCP so that, yeah, they opened it on their project, but the folder actually rejects that policy. So we haven't actually created risk. We've created a misconfiguration, but that misconfiguration didn't result in risk. At the end of the day, though, stuff like does slip through the cracks. It's a very big company. Sometimes misconfiguration happens. Honestly, some of the biggest failures we have in this space is when we're rolling out a new org policy and we find that there was an existing brownfield workload that was relying on the insecure or the broken behavior, and then we have to create an exception kind of on the fly and then do a remediation afterwards. But I do think like our misconfigurations tend to be few and far between because we operate in a defense in depth approach, which is obviously what we'd recommend to any cloud customer or even on-premise customer, is like, don't have a single point of failure in your security processes.
Yeah, and likewise, we do have detections around kind of overly permissive firewall, firewall ACLs, config changes, that anomalous account usage, that kind of thing, right? And so, while I'm not claiming to cover every single misconfiguration usage or use case, the ones that expose assets to the internet, for example, or the ones that provide, change the IAM policy to kind of provide, all rights to unauthenticated users. Those types of state changes, we definitely alert on, and even though the compromise hasn't happened yet, we'll reach out to the project owners and be like, something is wrong here. You might want to look at this right away.
That's amazing. And I think that I really love the passionate appeal to defense in depth, because I've met people who think that in a modern cloud native environment, it's less relevant. And I usually tend to get very angry at them for that, because it is very relevant, and it's probably more relevant in cloud native environments because you can do it well. So we're almost at time. So I want to kind of close this amazing discussion with by asking each of you to give either one tip or maybe a war story with hopefully a lesson about how to best secure environments that clients can use. Let's see. Should we do pre-fail first, post-fail second? Seth?
Yeah, I think I kind of alluded to it, but the one tip I have is like treat your infrastructure like code. And don't reinvent the wheel. You likely already have a code review process for your application source code. Hook into those processes, hook into CI/CD, like treat your infrastructure like code. You will get a ton of benefits. Google didn't always do that, which is the war story I have. When we were mitigating a large-scale vulnerability, we found there were instances where teams had a pathway to just go do ClickOps. They could click the buttons. And that meant our ability to scan those environments was incredibly more invasive because we couldn't rely on infrastructure as code as the only source of truth for what exists in those target environments. So if you're just starting out in your journey, or if you're, already all the way there, like make sure you're using infrastructure as code. There's lots of tools and technologies out there like Terraform, like Deployment Manager. Other cloud providers have things like CloudFormation, et cetera. If you're not using infrastructure as code, like start.
I already touched on it, logs normalization. If I could say one thing, it's logs normalization. But for the war story part, I think the word log4j carries a certain exactly a certain reaction in our circles, and so definitely want to hearken to that of in the log4j incident, like how important was having asset inventory? How important was it that you knew, or how important did it become that you didn't know what was running on your systems, right? And so for us, where we had that telemetry, where we had that visibility, it was a very, very straightforward exercise. But where we didn't, and we don't claim to be perfect, so where we didn't, it of course was a four alarm fire and 24 by 7 scramble. But I'll call out the log4j, while it took all the headlines, is not and was not the only backdoored, widely used library, widely used binary out there. Every Tuesday, I'm just picking a day, every Tuesday, every Wednesday, there's a backdoored binary somewhere, right? XZ, et cetera. SSHD gets backdoored all the time, et cetera. So, I just want to kind of reaffirm that you need to be able to reason about and see and have inventory and be able to know what's in your environment, because the threats are out there. The threats are constant. And without that visibility, again, normalize your visibility, but without that visibility, you just don't know how vulnerable you are.
Yeah. And if I'll add just one thing, like I think Tim hit on something there that I want to double down on. It's like, don't put all your eggs in one basket. Don't put all your resources in preventative controls, and don't put all your resources in detective controls. Like there's a very important balance here, because at the end of the day, 0 days, backdoors, et cetera, are going to happen. You should prevent as much as you can, but don't underinvest in either side.
Perfect. This is another eternal advice that people don't pay attention to. So thank you very much for the whole panel and for this advice as well.
Hi, I'm Nathan Brubaker, part of the Google Threat Intelligence Group. You probably have heard a lot about the evolution of the cyber threat landscape, but what about the threats themselves? In this in-depth video, we're going to explore the evolution of financially motivated cybercrime as threat actors and defenders adopt new technologies and tactics.
Every living thing on this planet has had to adapt in order to thrive. Whether it's driven by the environment, competition, or a threat. To survive is to evolve. This is the case for businesses too. They develop and they embrace new technologies so that they can be more efficient, profitable, and gain a competitive advantage. But whether it's stealing passwords via punch cards or mailing malicious software on a floppy disk, criminals have always looked for ways to exploit these evolving systems for their own benefit. In the early 21st century, an enticing target for criminals was sitting right inside everyone's wallets.
We saw breaches where threat actors essentially sat in parking lots and pointed antennas at retail stores and captured unencrypted credit card numbers. You could try to use the credit card numbers that you stole to buy goods, but realistically, you're only getting a few $1,000s worth of value. But if you think about how that actually worked, the adversary only had the ability to steal credit card numbers that were traversing from that particular store. And you've got to steal a lot of credit card numbers over a long period of time. And it's not really easy to make $1 million.
In 2013, credentials stolen from a third-party vendor provided access to Target's network, where malware could be installed on point-of-sale systems. Through this, cybercriminals were able to steal the credit card information of over 70 million customers.
And so what do they do with them? That's when they turned to what is commonly referred to as card shops. And these are shops that were specifically specialized in just selling stolen payment card data. And these costs, in some cases, just a couple dollars.
There's a significant amount of consumer trust that was lost because of these security events. A lot of folks were scared to shop at these stores. And so a lot of these merchants that dealt with these security events essentially had to do a few things. One, they had to figure out how their environment was compromised. Two, they had to secure their environment to stop the bleeding, to ensure that they didn't continue to lose credit card data. And the third thing they had to do is really tighten up their security controls such that it became incredibly hard for a threat actor to re-compromise their environment.
They really had to evolve and adopt new technology. And that's when we see chip and pin cards become really popular. At the end of 2015, there was a liability shift for retailers and financial institutions. Whichever one wasn't complying with this new technology, they would be on the hook for any losses. And so we saw a sharp increase in the number of organizations across the US that had adopted this technology. And that caused a strain on threat actors, right? They were no longer able to break into these companies and steal large volumes of data anymore.
But the nature of evolution is to react and adapt to new challenges.
When we start to see payment card intrusions go down, we also start to see a really small scale operation around ransom attacks.
It looked very different than what organizations see today. We were essentially seeing situations where a threat actor tricked somebody into installing software on their computer.
And what you would see as the victim is actually just this message that says, please pay me now. You must do it within the next 24 hours or else I'm going to delete all of the files off of your system.
And the amounts were quite small, $50 or $100 or maybe $500 or so. What changed over the years is we started seeing threat actors understand the organizations that they broke into. And one of the first groups to really perform targeted ransomware deployment was a group called SamSam.
They were not mass distributing ransomware to individuals like me and you. They were actually breaking into companies, moving throughout those networks, and then attempting to deploy ransomware on as many machines as they could.
They started increasing their demands. They started going to the high six-figure extortion demands. And then something that substantially changed at the end of 2019 was a group called Maze ended up conducting what we call multifaceted extortion.
They're already in these networks. They already have experience stealing data. Why don't we just steal what else we can find in these victim networks? And so that's what we started to see happen. And they basically said, hey, if you don't pay us, we're going to release this data publicly on this forum. And that's what we saw them do. That victim didn't pay, they released the data. Since Maze really invented this kind of approach, we saw other threat actors adopt the same approach. And as of today, there's more than 150 of these different data shaming websites to publicize breaches and to post data that they steal from victims.
No longer were people just paying to recover their business operations, but they were paying for a promise for this stolen data to not show up on the internet.
We're now at a time where we have threat actors commonly demanding over $1 million from a single victim company. And financial institutions had gotten really great at combating fraud. Like that is something that they had been experiencing for years. And so you see cyber criminals start to rapidly adopt cryptocurrency. And instead of demanding payments for ransom in the form of prepaid money cards, they're demanding payment in Bitcoin instead. That gave threat actors another way to be able to receive payments from their victims that was a lot more untraceable.
It also changed the nature of who is a victim. Because if cryptocurrency and getting it and extorting organizations is the goal, that means that really anybody can be a victim of cybercrime in this new era.
Naturally, people have begun to specialize and fill niches, giving threat actors the ability to design their approaches with increasing complexity.
And so we really kind of saw ransomware evolve into really this broader extortion machine.
And we're tracking the system of systems that these criminals are using in the underground to really carry out their schemes.
So you might see something like 10 to 30% of whatever that ransom is paid in the end go to that initial access broker. Those are going to be people that are really good at infecting those initial machines. So they'll send spam emails, they'll use exploits, and they'll distribute malware, and that's kind of where they'll stop. And then you might have another 20 to 30% that actually goes to that ransomware developer or service operator. And then the remaining amount would go to that intrusion operator. And these are the people that know how to move throughout a network. They know how to escalate privileges at an organization. There were a lot of different ways effectively that those threat actors kind of developed and expanded the ransomware as a service offering beyond just providing a piece of malware itself.
So, now you have a multifaceted, multidisciplined industry that's becoming as sophisticated as any other modern business. But what's the next big evolutionary step for this industry?
We know that threat actors are using AI to experiment right now.
What is fact and what is fiction becomes harder to tell. Is this legitimate? Do they actually have these pictures of me?
But what's more exciting is what defenders are doing with AI.
At Google, we've been using AI for many years as a source of good and as a force multiplier.
We're using it to help look through source code and identify security vulnerabilities. And we can do it at a faster rate than which the adversaries can do.
We're going to continue to advance the capabilities that we have there, and we're going to be able to continue to make those capabilities available to our customers and to our users.
The Google Threat Intelligence Group relentlessly defends Google, its users, and customers by building the most comprehensive threat picture to disrupt adversaries. We're really committed to making sure that not only Google is safe, but those organizations that depend on us, as well as the entire global security community. But we still have to be vigilant because we know threat actors continue to get better and better at using AI as a tool.
I hope you enjoyed that view of how adversaries and their tactics have evolved over the years. As we mentioned in the video, AI is an increasingly critical tool that's helping our analysts and researchers cover more threats faster and with more accuracy. I'm excited to share a few examples of how we're integrating the technology across all levels of the intelligence creation process. This process involves taking raw intelligence data from a range of sources, structuring it, and then processing it to extract valuable threat insights that we can then use to help defend Google and our customers. For example, this includes leveraging AI to ingest incident response data, automatically generating first drafts of research and reports that can help answer customer questions, and everything in between. In order to support Mandiant Consulting and Google Threat Intelligence customers, we need to ingest massive amounts of data from consulting engagements and then bring them into our internal systems. We've built a range of tools to help us scale this work. One example is this capability. It takes incident response timelines that can include many, many thousands of events, related malware, and other types of data, and then it uses AI to synthesize that data down into a paragraph overview of the engagement. This can be easily validated by analysts and ingested into our systems. Another example of how we use AI to process raw data is this capability. It takes videos or images from hacktivist claims that relate to exploitation of certain systems as an input, and then the tool analyzes those videos or images and produces a detailed description of what's occurring in the video, and then outputs a brief summary as well as metadata that our analysts can review and add to our databases. To help scale our ability to cover threats to significant events, things like the Olympics or elections, we continue to build tools like this one, which is able to take domain data as an input, process it using a version of Gemini that's fine-tuned to the specific event being covered, and outputs lists of prioritized domains that a human can review. Using an early iteration of this tool during a recent significant event, we were able to triage over 20,000 individual domains, with the AI flagging a little bit north of 4,500 of them for a human review. This led to 49 leads that would not have been discovered otherwise and saved several hundred hours of time. This innovative research focuses on using AI to attribute phishing emails to known advanced persistent threat groups. We built a model that can attribute new phishes to the relevant threat group with relatively high accuracy. This tool leverages 3 submodels that focus on different aspects of the emails. In the first model, we use stylometry, which is the statistical analysis of linguistic style, in written or spoken language. And the second, a language model, which analyzes text by considering the context of each word. And in the third model, a large language model, which can extract key contextual elements from the emails. We can then combine all three models with the meta model that achieves an impressive accuracy of 88 to 96%. The growth of hacktivism and hybrid threat activity over the past few years has really driven us to build innovative solutions to expand our coverage of the threat. In addition to using AI to extract insights from specific hacktivist claims, we've built several capabilities that ingest massive amounts of forum data and can output customizable reports for different purposes. For example, using AI, our analysts can create hacktivist actor profiles in about 10% of the time it would have taken them to do it by hand. We can also use the tool to identify things like actor claims related to significant events or campaigns, or activity associated with hacktivist ecosystems. Google Threat Intelligence Group has a long history of producing industry-leading finished intelligence reporting, all the way back to the APT-1 report from Mandiant. We've been working on a range of AI-centric capabilities that allow our analysts to offload lower cognitive work to AI so that they can focus their time on more complex analysis and critical thinking. These efforts focus on connecting all of our internal threat databases, finished intelligence reporting, analyst research, and more with fine-tuned AI models that analysts can use to output initial research and reports in a first draft mode. We have seen significant successes already, with some of these report types taking 50 to 70% less time to create than before. All right, that's all I've got to share today. I really hope you found some of these examples interesting and maybe even inspirational. As Google and the rest of the cybersecurity community continue to innovate with AI, I'm really excited and optimistic about how the technology is going to empower cyber defenders. Thank you.
Hi everyone, my name is Brandon Levine and I am the Senior Product Manager for Curated Content and Detection Experience here at Google SecOps. Welcome Steve, you are one of the frontline members of Google SecOps' Mandiant Hunt. So let's dive right in. Your presentation mentions a fairly concerning trend, particularly around exploits as an initial infection vector, are actually increasing over time. Can you elaborate on what's driving this increase and why should organizations be particularly worried right now?
Yeah, hey, I'm Steve Sedato, a security analyst and detection engineer for Mandiant Managed Hunt. So over the last couple of years, we've seen a pretty steady trend of exploits being the leading cause in a lot of the IIVs across exploitation attempts. So we've seen 37% in the 2022 M-Trends, 32% in the 2023 M-Trends, and then we saw a 6-point increase over the next year, topping off at 38%. Also to include that these numbers are even higher in the Americas, totaling around 41% in the Americas and 39% in the APAC regions. So I think what's going on here is we see attackers continue to utilize these exploits through the attack lifecycle to maintain access, move laterally, and complete their mission. So what we've also seen is that we've seen an increased focus in evasion. So a lot of these actors are targeting edge devices, applications, software in an effort to maintain persistence across networks for as long as possible, using living off the land techniques and exploiting zero-day vulnerabilities.
So you mentioned zero-day exploits and zero-day vulnerabilities, and these used to be this almost mythical $1 million sort of bounty scenario, really highly specialized, and you're saying that they're becoming a little bit more common. Is this just because attackers are getting more educated, more capable, or are there other factors at play making zero days a bigger part of the threat landscape?
Yeah, great question. So I think it's a little bit of both, actually. So what we're kind of seeing across is we're seeing trends that these exploits are no longer limited to a few select actors. So historically, we've seen these things come from very sophisticated, very coordinated threat actors such as APTs. However, we're starting to see a trend in increasing availability, which is expected to continue due to a couple different factors. And this can include things like ransomware being so successful, data extortion groups utilizing exploits, and then the continuation of state-sponsored activities and exploitation. And then lastly, there's a final point I'd like to make there is that there's also been a rise of commercially available turnkey exploit kits. So essentially, threat actors are selling exploits. And there's also other things, post-exploitation, such as like ransomware as a service. Initial access brokers are becoming more common. So once they get that initial access, they're selling off that access to better threat actors. And then lastly, additionally, we're seeing a lot of bugs in third-party components and libraries were found to increase. And this is partially due to, I think threat actors are starting to come to the realization that if they can find bugs and vulnerabilities in libraries, they can affect multiple products rather than targeting a specific application or program.
Do any examples come to mind of those types of situations? Because that's really interesting. You're almost looking at sort of a supply chain sort of compromise, although that's a very weighty buzzword in some places. It is actually the case that is happening in the exploit realm.
Oh, 100%. And there was a joint collaboration between Mandiant and Google Threat Analysis Group, so the TAG group, where they came up with their first ever joint report that I'd like to briefly shout out. So this was titled "We're All in This Together, a year in review of 0 days exploited in the wild in 2023. And what they found was that there was a CVE titled CVE 2023-5217. And this was a flaw that affected more than one browser. So essentially, it's a buffer overflow attack in a specific library, a codec library, and essentially this vulnerability affected Chrome, Firefox, iOS, and Android.
So that's pretty pernicious, right? Like that's pretty much everything.
Right, exactly. So you're talking about 4 major applications or programs that they were able to affect via a single vulnerability and or bug.
So are there other key findings from that particular report that you'd like to highlight?
Yeah, there's a couple findings that that those groups highlighted. So for one, in 2023, there was 97 unique vulnerabilities that they found that were exploited in the wild. And these were particularly exploited by Chinese Nexus cyber espionage groups, being the most prolific attackers. We also found in 2023, there was 36 0 days in the wild targeting enterprise-specific technologies. So this kind of emphasizes the recent trends that Mandiant has identified with increasing diversity in the types of products that are being exploited and a decreased reliance on browser-based and document-based exploits to be successful.
That's a really interesting point, because cybercrime threat actors have really historically relied on these browser-based social engineering document-based exploits or more enticement-based social engineering attacks. How has this shift really materialized in the realm of cybercrime? I know we've seen some major hotspots from nation-state threat actors, but let's talk about cybercrime as well.
Yeah, so a recent trend I can kind of think of within the last couple of years is that there was a big uptick in 2022, 2023 of where particularly the Quackbot threat actors, they're really targeting like MS Office type files, right? So think of your XLS, your docx. So they were sending these to emails. And I think the end user is very likely to click these kind of files because they're typically they're business ready file types, right? So like getting a docx or an XLS file via email isn't very suspicious. But I think what we've seen over the last couple of years is that vendors are being very much more proactive in enabling better security postures by default. So for example, I think Microsoft disabling macros by default really caused a shift in seeing the downfall in a lot of these kinds of attacks. And that's not to say we don't see, these specific attacks come through email. So particularly like in the past couple months, we've seen a lot of like WSF files, particularly being, fake resume, fake job description, different type of variants of HR type documents. But this shift is kind of shifting away from that, and we're kind of seeing more exploitation of security software and appliances. So some big ones that come to mind is the Barracuda email security gateway, Cisco adaptive security appliance, Avanti endpoint manager, any of the VPN appliances that have been targeted over the last year.
And why would threat actors focus on those types of appliances? I mean, those are meant to be securing your enterprise, and the expectation is that, hey, these are the most secure of the secure things. Is that not necessarily the case?
Right. So I think threat actors are particularly interested in these devices is one, because they're on the edge. So they're accessible from the internet. Essentially, there's a lot of threat actors that can do mass scanning and find these vulnerable servers, find these vulnerable appliances just by conducting mass scanning activities. And then they can essentially try to do mass exploitation of those. And then also, if they are successful in breaching these edge devices, a lot of these are ran with high permissions, which allows easier follow-on activity. So essentially, they've got some keys to the castle straight from the get-go. So Mania has continued to observe cyber espionage and financially motivated actors leveraging these vulnerabilities to conduct their operations, with financial gain being one of the primary motivations. And just to kind of go on to that, since we're talking about edge appliances, I want to take a quick second to shout out some of my colleagues who came out with a really good blog series called The Cutting Edge. It's a 4-part series investigating some of the recent Avanti compromises. And for anyone who's interested in edge device exploitation, zero-day research, I would really go and take a read into those blogs, because at the end of the day, you see a lot of similarities between how these threat actors kind of conduct these activities on edge devices. So they bring up some really interesting points in those series, along with the Mandiant Defender's Advantage podcast, particularly like some hot topic items that we've seen, such as the uptick in zero-day activities that we've seen in the last few years, some of the exploitation pre and post disclosure. So if the vendor comes out that there is a vulnerability, generally we see an uptick in exploitation attempts because they know that avenue is kind of burned. And then lastly, there's some insights and some of the handoffs to different threat actors post exploitation.
With the recent Black Basta leaks, I don't know if you've had a chance to browse through those chats, but I have nothing better to do on my weekends, unfortunately. There were something like 50 different exploits mentioned by either identifier or by reference in those chats, and this is has been one of the apex threat actor groups for cybercrime, especially hands-on keyboard ransomware. Does that surprise you at all?
It doesn't. I think we've seen a lot of coordinations, and I can't speak on, Black Basta specifically, but we have seen a lot of coordination and handoff and cooperation between threat actor groups. Again, just kind of talking from that initial access broker type stuff, they're not necessarily opposed to handing it off to other TAs at this point. So it's not like what we've seen sometimes in some of the historical trends to where an APT doesn't really want to hand off that access, right? So we're seeing a lot of, again, kind of as we talked about, the accessibility and some of the the gap to kind of that initial level of exploitation is kind of lowered over the past couple of years, and we're seeing more actors kind of abuse that. That really doesn't surprise me. I haven't read into that specific one, but yeah, I'm not super surprised about it.
You mentioned an emphasis on threat actors attacking using exploits on edge-based devices. Are you seeing an increase in exploitation across the attack lifecycle? Like as you move a little bit further to the right of Boom, as attackers get deeper into networks, are they still using? Have they changed their tradecraft to emphasize more exploitation rather than some open source tooling?
Yeah, so it kind of is a mix of both. So, you're always going to see a lot of open source tooling, like, a lot of open source proxy tools tend to be in use. Even to this day, a lot of, pen testing frameworks are still being used, like SMB exec, WMI exec, Sharphound. You still see a lot of those types of follow-on post exploitation in these breaches.
So let's change gears a bit and talk about how SolarWinds changed the way that we hunt as security experts, because SolarWinds was really a bit of a watershed moment for us as an industry, and particularly for Mandiant, right? So can you shed some light into how our thinking has changed post SolarWinds?
Yeah, so SolarWinds really changed the way we hunt and why we believe that Google SecOps enables our methodology moving forward to be successful. So just for a quick recap, I'm sure everyone knows at this point, but SolarWinds was the supply chain compromise where the APT29 actors inserted malicious code into the Orion software, essentially as an update. So what we saw from AP29, Russian nexus, historically targeting Western governments, foreign affairs, government contractors, and universities, just to name a few. What we saw from these guys was they had high operational security, right? So very, very challenging to leverage the traditional IR life cycles based on some of the historical findings we have. So there wasn't much of a reactive capability there because we had no past data to go off of. They also had a very sophisticated knowledge of forensic practices. They leveraged many accounts not to identify all their infrastructure the threat actor interacted with. They did things like writing malware to known directories to blend in with legitimate operations. And then lastly, they were very good with not utilizing the same indicator twice. So reactive capabilities were slightly cut down. And this wasn't the last we've seen of this group, right? We've seen them as recent as last year. CVE 2023 42793, which many of you may know is the JetBrains Team City compromise, which was an authentication bypass leading to remote code execution. So CVE 9.8. So we also saw this CVE utilized by quite a different bunch of different threat actors. So we saw North Korean nation state actors, the Beyondlon ransomware group also utilizing the exploitation. So again, kind of mentioned earlier is that we're seeing these exploitations used across a myriad of different threat actors from different origin countries, different motivations.
Interesting question. How rapidly do exploits propagate in your experience? Like, is there sort of a delta between, okay, this is a 0 day and okay, everybody else is using it. And then of course, inevitably the crypto miners use it, right? Like, have you seen a change in that ecosystem or that environment?
Yeah, I think kind of as mentioned in the blog earlier is that once that vendor release comes out, we see a lot more smash and grab, right? The threat actors kind of start to scramble because they know that exploit is kind of been discovered. So they may try to grab configuration files off firewalls. They may try to grab credentials where they can. Essentially, we do see an uptick in activity, mass scanning, and a lot more of the smash and grab style to kind of get, the important stuff when they can, whether that be data extortion. Maybe they didn't find the data they were looking for, but anything is better than nothing at that point. So we start seeing exfil. But yeah, so essentially once that comes to light, we do generally see an uptick in that kind of attack.
And before you highlighted Google SecOps as a key enabler for your hunt strategies, and how does SecOps specifically empower Mandiant to implement this, what you've referred to as the detection funnel, and handle the increasing volume and complexity of threats, especially things like 0 days?
Right. So great question. So this is the funnel concept isn't really anything that's new in the detection world, right? You take a lot of data and you funnel it down to as minimal data as possible. So essentially, after the SolarWinds attack, we realized that we really needed to try as best possible to reduce false negative by overly complex and specific detections, right? So what that can mean is for any detection engineers or for anyone who's previously created detections, right, they can be very fragile. So things like if you have a contained statement, an extra white space could make you miss that key piece of forensic evidence. Or if you have a regex statement, a regex match statement, the same thing, right? Something as simple as an extra white space could cause that detection to be missing, loads of forensic evidence. So how are we using Google SecOps to kind of enable this new hunting methodology, right? So essentially what we want to do is we want to label anything that's security relevant and label it and capture it within SecOps. So think of things like, and I'll kind of go into this a little bit later, think of things like any file, right, to any suspicious directory, right? Think of process chaining. So think of like a process tracker of like WScript launching, CMD launching PowerShell. We want to be able to label all this stuff, not necessarily cause an alert, but just have that captured. And then we want to correlate all that data. And how we do this is that Google SecOps allows us to enable a very high detection limit per day with aggregation and correlation capabilities. This provides us a path to broad to build broad labeling rules and label security relevant events. And it also has the ability to let us create multi-rule capability, so multi-event rule capability, which allows us to correlate and chain together as many detections as we want. So what this allows us to do is it allows us to still capture that security relevant data. So think of how many investigations start with a who am I, a Q user, a host name, right? Typically, those are too noisy in pretty much 99% of environments to cause a alert, because you're going to be your SOC analysts are going to be spending all day on that single detection. But if we can capture and label that, we essentially knocked a significant amount of web server compromises out of the park right there just by that single alert. And then we can correlate further detections, start building on top of that, and then present all of that data to the SOC analyst to essentially capture, correlate, have all the security relevant data in a single case, and then quickly triage that and get to the customer as soon as possible.
Awesome. Let's dive in a little more into the actual hunt identification layer, particularly when it comes to the inputs for composite or chain rules, which we typically call producer rules. So you've talked about Mandiant's hunt detection strategy. Can you break down for the audience what the strategy looks like at a high level? What the core philosophy is behind it? And then let's dive into the actual identification layer itself. There's trackers, GCTI, anomalous signals, and vendor signals. Can you also give us concrete examples of what kind of detections fall into each of these?
So essentially, we have a multi-pronged approach, generally starting with identification layers you mentioned. So these are our producer rules. These are our single event rules that are security relevant. And then we go into the classification rules. That's where the grouping occurs. And then we turn the events in the classification rules into detections. That's what the SOC analysts will triage, SOC and hunt analysts. And then those go into cases, and then they go into reports. So you can think of the identification layer as about identifying events that have security relevant characteristics. So for us, we generally define this as threats we've observed in our MD investigations, gathered from third-party research, anything we can get from cross-team coordination, whether that be our threat intel teams, our incident response teams. We don't intend on the detections generated at this layer to be reviewed directly one-to-one, right? So they're meant to be correlated at the classification layer. With what we then do is then we score these detections. So I think risk-based detection isn't anything new necessarily, but doing it at scale is a very interesting and complex process, right? So we can use modifiers, which we can apply broadly. So for example, if we see an asset as a server, we can add an elevated risk score to those detections, right? Because anything that's kind of suspicious on a server should probably likely be, not necessarily more likely be investigated than a host, but it may require more urgency, right? So if we see a who am I on a web server, it's a little bit more interesting than seeing that on a single workstation, right? And then once they reach these thresholds, that's when we can isolate the cases. And then we provide a better hunting experience by leveraging outcome variables, which allow easier stacking. So that's kind of it from the high level.
Awesome. Do you want to drill down into the different categories of how we think about identification rules?
Yeah, I'd love to talk about this because this is kind of my bread and butter. This is my everyday work here. So we essentially label, or going forward, we're going to label our rules into pretty much 4 separate categories, right? First, you have your trackers. So the really awesome thing about trackers is that we can use automation to help us identify and create these rules for us. So kind of like I was talking about earlier, the process chains, right? So if we see process chain, think of like a child process, parent process, grandparent process. If we see all of these 3 in an MD investigation, we can automatically create a rule based on that triplet. And then that may be security relevant, and that may be something interesting we want to look for. So for example, in a case, if we see WScript launching CMD, launching PowerShell, that may be indication of a malicious JavaScript file, malicious VBS file, something that we may want to look into, but not necessarily that anything that may not be caused by automation, but something that's security relevant.
But specifically, each one of those is an individual detection, and there's no real intent that an analyst would work the individual detections. It's the composite effect that is occurring here, that it really generates the interest and elevates us to a potential alert for you. Is that correct?
That is 100% correct. And we'll get into the classification here in a bit, the classification layer, where we kind of talk about how, the different methodologies and how we can kind of rack and stack those detections together to create something that's a little bit more interesting, a little bit more likely of being malicious. So I also kind of want to segue to and also kind of talk about the other kind of trackers we have. So we can also use trackers for file rates. Again, kind of what's interesting is, how many times can threat actors write to program data and not get caught, right?
Classic, right? It's classic technique.
Somewhat benign, somewhat potentially malicious, right? But we want to capture that. And if we could do that at scale, replicating that across numerous directories, right? So think of program data, think of music, think of pictures. We capture every single file rate that's written when a file is written to those specific directories that we've seen in past investigations. Eventually, a threat actor most likely has to write a file somewhere. So we're going to capture that data, and then we're going to eventually feed that into our classification layer. Then we have the GCTI rules. So these are a little bit more Intel-based. These are going to be things like pinpointing connections to Tor exit nodes. Also, things like tracking file writes of remote access tools, known hashes of remote access tools. So again, something that we've really seen an uptick in is that threat actors really love using remote access tools, things like a Terrace, Splashtop, Level.io. I find it really intriguing that they use legitimate remote access tools, and how we can use that, right, is if we don't see that hash previously in an environment, or if it's a first-time detection on a known remote access tool, that's interesting to us, right?
Wait, did you say you could detect on the first time you've seen it in an environment?
Correct. So Google SecOps has what they call the entity graph. So the entity graph allows us to look at context within specific environments and determine, is this the first time we've seen this hash? Is this the first time we've seen this IP? Is this the first time we've seen this domain, right? So that kind of rolls into our next one, which is the anomalous signal. So we can create detections to where we can kind of use a multi-event rule to where if we seen a first seen in the environment, just as a broad example, first seen hash in the environment in 24 hours, spawning a network connection to a first seen domain in the last 24 hours based on entity graph data, that seems forensically interesting, right? So we have a new hash, we have a new IP. That may be something we want to add in this producer rule layer. And then lastly, as many of you know too, Google SecOps, we are fairly vendor agnostic. So we also correlate vendor alerts because there's no reason to not use, telemetry from other vendors as well. So this could be, anything ranging from informational to high or critical. We could also use that to rack and stack in our funnel methodology.
Great. So let's dive a little bit deeper into the full funnel itself and really where the magic happens, which I think is definitely some form of black magic in the classification layer.
Yeah, awesome. So this is a by the numbers. These numbers are based on a customer we had ranging approximately from about a week or so of event data, right? So this kind of plays into, we're going to talk through a real world example here in the next slide, but this is what we saw in their environment over the course of a week. So as you can see on the left side, this is the base of the funnel. This is where we ingest all of our vendor telemetry and as events. So this could be EDR data, this could be network data, this could be cloud data, identity data, firewall data. It really doesn't matter. Whatever you send to us, we can use. And then next, as you can see, we had billions of events in that first layer of the funnel. Then we go into the next layer of the funnel, which is the identification layer. This is where we label our security relevant data. This is what we use as the building blocks for classification rules. We essentially want to minimize any filtering capabilities on top of these detections because, again, we don't want to miss anything that may be forensically important, right? We want to capture that data. We don't want to necessarily alert on it per se, but we definitely want to capture it. So, for example, one way you can think about this, if we do a quick shift to like cloud, A detection at the identification layer may be a single API call, right? Or if we go back to endpoint data, a detection may be curling, pulling down a specific suspicious file. So we don't want to necessarily do too much filtering, but if we see curl for like a PS1 file, BBS file, MSI file, it may be a little bit more interesting. But we want to minimize filtering there. Then we go into the classification layer. So you see, we see 10,000 events at the identification layer. Then the classification layer, we have 58 detections. So this is where we produce actual alerts or hunting leads based on the identification layer detections. And again, this could be single or multi-event. I don't want to kind of downplay the effect that there may be single event detections that we just have to triage. They may be that, forensically important that, we need a SOC analyst or hunt analyst hands-on to kind of identify, triage that alert. So typically anything that's been a little bit higher efficacy may be something that we see in those single event rules.
I assume those are things like IOCs from Intel sources, things that are a little bit higher fidelity and have a higher confidence level, right?
Correct. Yep. Generally speaking, anything that higher efficacy, higher impact are going to be kind of those single impacts or single layer event detections. And then also at the classification layer, we can also provide enrichment and or lead generation. And then lastly, we could correlate rules there.
Awesome. So we've gone over like how you do it, why you do it, and really what has changed since the times of SolarWinds. But really getting back to the idea of exploits, what have you seen that's out there? Like, what are some real world examples of some of the things that you've encountered as a detection engineer?
Yeah. So one of the recent ones that came to mind, I wanted to kind of talk about this one because this was a fairly recent one that we've seen in the last 3 months or so. This was a multi-system compromise that we've seen and reported on using Google SecOps. So this is a real-world success that the Mandiant Hunt team, leveraging SOAR, recently uncovered with that multi-system compromise that bypassed traditional security alerts. So what we saw in this attack was exploitation by UNC5883, and they exploited a vulnerability in Oracle web servers, gaining remote access, installing third-party remote access tools, and creating a local administrator account across 3 different servers. So who is UNC5883? They're a threat cluster of currently unknown country and motivations that have exploited the CVE, as in this case, CVE 2024-20953, which impacted Oracle Agile PLM servers. So essentially, what the PLM server does is Oracle WebLogic provides the infrastructure to run the PLM functionality effectively. And so what the CVE website essentially said about this is easily exploitable. It allowed low privilege attacker with network access via HTTP. And it's a great time to kind of talk about this intrusion specifically because CISA actually just added the CVE to their known exploited vulnerabilities catalog yesterday. And as I mentioned, throughout the course of 3 days, we saw various levels of exploitation and enumeration across 3 different web servers.
And this happened, what, in 2024, late 2024, you said?
Correct, early November.
Oh, wow. Okay.
Yep.
So y'all were way ahead of the game.
Yeah.
Awesome. So what else did you see here in the context of this attack? You saw this exploit, but the exploit is really just a means to an end. What else did you actually see these threat actors doing within the environment, and what ultimately happened?
Yeah, so the exploitation kind of occurred with your typical web server type enumeration, right? Again, kind of as I mentioned earlier, we saw who am I, we saw queue user, and we saw a bunch of different enumeration commands. And again, this affected 3 different servers over the course of 3 days. So essentially, we saw the first host be exploited with that vulnerability. And then the first indication of malicious activity was actually one of our file tracker alerts. What we saw was a PS1 file being written to a suspicious directory. And this was the first indication of attack. And we also had a methodology detection on this. So methodology being kind of your standard detection logic, with what we actually saw was a PowerShell invoke web request What it was doing was it was calling for a remote resource and outfiling into an exe file. Right around the time that we saw this detection, we did see a third-party interactive shell alert kind of spawn on this host. So if we kind of compare the timelines, just to kind of give you guys an example of what this slide is actually showing, is that top line is what we saw in managed defense, and the bottom line is what a standard vendor saw. So standard vendor detections. So what we saw is that we had, the first hint was that we had a suspicious file, right? And then we had that suspicious methodology alert. Then we had in one of those anomalous signatures that I mentioned. So we saw a new process interacting with a new remote IP. And this could have been, if I recall, they dropped an exe file. The exe file started spawning outgoing network connections via HTTP. On the same day, and again, like I mentioned, so for those anomalous detections, right? So those are all based on entity graph data. And that can include, not only does it include, first seen type stuff, it includes, you can enrich data with like who is, safe browsing data. You can do GCTI data and also things like virus total metadata. So there's a lot of options there of what you can enrich these detections with using that entity graph data. So shortly after that, we saw some failed attempts to download a rat. So the first one failed. I don't remember the specific reason of why that failed. It might have been stopped by the EDR. But then we saw a second install attempt, and that one was successful. So there were two different remote access tools, actually. So they tried two different methods to get that onto the host. So then on that first host, we also saw that we had a blocked malware event. So again, this kind of tells a story that we see malicious interaction on a host, and then we see a blocked event. In a lot of minds, that may mean that the attack stopped, right? That it was prevented by the EDR. And without further investigation or without further, further detections or alerts or any kind of telemetry on that host, it's very likely that, a client may think that that attack was generally prevented. But what we saw shortly after was we saw a second server affected. We saw those same enumeration commands. So on that first host, they had actually stopped. And then 2 days later, we see further exploitation on the third server. And this third server followed pretty much the same similar kind of attack chain. But in this case, we see a lot further exploitation. We see a lot more commands. They pulled down a couple extra malicious files on that host. So needless to say, from a vendor point of view, this attack stopped 2 days ago. But with these, identification layer detections, we had a lot more data to go off of. And we actually found out that they were in a worse position than they had initially thought. And quickly after this report went out, these folks went to incident response.
Yeah, it seems like they may have been a little bit of a mess here, but it sounds like we were the team was really able to use the power of SecOps and SOAR together, and some of our hunting strategies to really nail this attacker to the wall.
Yeah, that's the perfect way to put it. So SOAR also has some really good additional features too, right? So they have the ability to use case similarity. So essentially what the case similarity do is it connects the dots between seemingly different events, right? So it revealed the true scope of the compromise. What it does is it shows linked entities, which shows the IP addresses, the usernames associated with the case. We see related cases, which shows similar scores based on a similarity score. And then also, and not lastly, Gemini provides a case summary. So all of this together, what this did is it quickly showed us every single piece of data that we had all correlated into a single pane of view. So this being case similarities, any malicious command, username, event associated that we had logged. And then we had an overview of Gemini summarization, which included, important items forensically, such as like a file was created and a PowerShell script was launched. PowerShell was launched on an asset that was a server. So again, now we start seeing the server stuff. And when you're an analyst within SOAR, that kind of information is very important to get quickly, right? And then lastly, we saw, they correlated some network events that we saw, remote IP was accessed via a remote access tool over port 80. So again, with all those three things together, case similarity, linked cases and assets, and then Gemini, we quickly showed 3 hosts, which have all been compromised over the course of 3 days, quickly had all that data correlated and put together in a single pane of view. And we were able to get that report to the client, and they were able to quickly remediate with the assistance of IR.
Thanks, Steve. I really appreciate your insights into this particular attacker and also into the general hunting strategies and how this has changed over time as for our organization. So to wrap up, as we're approaching time, what is the most important takeaway you want the audience to understand about detecting exploits and building a strong security posture in today's threat landscape?
Yeah, great question again, too, and thanks for having me. So while zero-day threats are difficult to defend against, you have to think of defense in depth to help reduce potential impact. So, I'll follow all the typical stuff, right? Networks, segmentation, vulnerability management, least privilege, but particularly, my one piece of advice would probably be don't be too afraid of some noise, right? You don't want to overdo your SOC analyst, but you also don't want to miss out on very important events that could essentially lead to an incident. So think of your threat hunting operations. Don't be scared of a little noise. Give them some flexibility. Maybe have an experimental queue where you could put detections that don't necessarily need to be triaged by anyone at a specific time, or any SOPs or anything like that. Let them hunt. Do good and be well.
Thank you, Steve.
Thank you.